All right. Chapter 7, Identity and Security in Google Cloud. All right. In cloud computing, security and identity aren't just checkboxes. They're foundational design principles. In this chapter, we'll explore how Google Cloud Platform protects infrastructure and data while giving administrators full control over access, roles, encryption, and auditability. We'll cover GCP's layered infrastructure and platform security, identity and access management, key management service, cloud security scanner, data loss prevention, and multi-factor authentication with security keys. But before we dive deeper into observability, let's step back and ask, what makes this meaningful without security? After all, you can only monitor, debug, or trace systems that are fundamentally trustworthy, and trust begins with infrastructure. Layered security from Earth to orbit. Google Cloud Security is not just a feature. It's a full-stack design principle with multiple layers of protection, including physical hardware security, service deployment protection, user authentication controls, data protection mechanisms, and encrypted communications. Let's explore each layer and how to effectively implement them for your cloud architecture. 1. Hardware infrastructure, security by design. Security begins at the physical hardware level with Google's custom servers, motherboards, and security chips. As a cloud architect, it's important to understand these foundational security elements, though you won't directly configure them. The exam relevance is this. During the exam, you may be asked about security responsibilities in a shared responsibility model. Remember that Google manages physical security, but you're responsible for securing your applications and data. 2. Secure service deployment, identity-based security. Each service in Google Cloud has its own cryptographically signed identity, established by a zero-trust security model. How do you implement this? Well, you can do this by implementing a service account. So, easiest way would be in the GUI here, where you click Create the Service Account. However, you can also do it from the CLI. Let's load this up. We're going to authorize it, and then we're going to create this service account. Now I'm going to copy and paste command. gcloud IAM service accounts, that's the command, create my service account. Display name, quote, my service account. All right. So it created this, and we'll do a refresh, and then you'll see this here, my service account. All right. So there's no keys, no ID. Now we're going to grant specific roles to this. Okay. Now the two roles we're going to do, we could do this here in the GUI, clicking here. All right. And where would we go? The description, advanced settings, domain name, delegation. We're going to go to permissions. Permissions here, we can grant access, add principals, that'd be your email accounts for users, domains, or service accounts, and then the roles, right? And then these roles would be specific. These are general roles for the service account, security, token access. Then there's cloud migration, specific applications like Dataproc, Earth Engine, Firebase, and you can see all the way down. And you can also manage these roles after the fact, all right? Or we can add it through the CLI. And you'll see this Google Projects add IAM policy binding to this project ID, to this service account, with this email address that we said. And then these will be the roles for storage object viewer, right? So that means it could see anything in the storage, okay? And you can assign that resource like the object viewer. So the exam will test your knowledge of proper service account usage, scope limitations, and key management. Remember to always follow the principle of least privilege when assigning roles. User identity and user identity and authentication, implementing strong controls. For human users, GCP provides multiple authentication options to ensure secure access. So how do you implement this? Okay, let's see. So let's go for this in security. Two-factor authentication. And let me see if I can find this. We'll copy paste. Two-step verification. I don't see this. Multi. Let's see if it's under multi-factor. No. Huh. I am not seeing it. Two-step. I don't see it. That's unfortunate. Okay. Multi-factor. All right, let's try this. Let's click this over, and I think it must be this reCAPTCHA. All right. So you have multi-factor authentication here via the Google Cloud Console or the CLI, MFA. So this is for personal accounts on or after May 2025. Enterprise, Q3 2025. Enterprise counts with Federation. That means it'll be your Google Workspace. So let's see. We go to the console. Now that's just a CLI overview. That's not going to be as useful. I don't see it here, which is unfortunate. reCAPTCHA help protect your website from this. So this would be something from an outsider looking in. I'm going to enable it because I'm probably going to use it at a certain point. So let's see. Do we see detections and controls, reCAPTCHA, sensitive, data protection? That's not quite it. API access policy. This is getting closer, but this is not exactly what I'm looking for. Let's see under security. No, under IAM. Principals, organizations, service accounts would be there. Maybe it's Work Identity Federation. No, that's for the Kubernetes. No, that's not exactly it. Oh, I feel bad. Privacy and security, data protection. We're getting closer. We're getting closer. It's going to be here, but essentially, two-step verification would do something like send you a text code, or it would make you sign in with an Okta, and then at that point, you could go through this and have your authentication to your platform be more than just your password. All right. But there's also other ways to do this. So let's see. I don't see it there. We'll see this there. So KMS. All right, let's try and say, so keys, right? So another thing you could worry about is keys. So with this, these keys are what you would use to encrypt your service, right? These would be an additional two-factor authentication management, right? So the exam will test your understanding of authentication methods, their strengths, and the appropriate implementation of four different scenarios. So be prepared to identify the most secure authentication method for various use cases. For this, you would have, in general, a service account with limited access, like you see here, App Engine or Compute Engine, or Kubernetes, or something along those lines. And you would have an encryption key, which this should have over in this column. But those would be the ways that you could limit access and encrypt to make sure that you have the strongest method possible. That paired with two-factor authentication leaves you in a good position for having a secure environment for your authentication and identity management. Storage services, number 4. Storage services, securing data at rest. All data stored in Google Cloud is encrypted by default, with additional encryption options available. So how would you encrypt this, right? Technically, you would use this with customer managed encryption keys. Let's see if we can find this. So let's see. Man, it is very difficult to find stuff these days. All right, so let's see in the security. Key management. There we go. That's probably it. All right, so in this, you can create a key ring with customer managed keys, or you can have AWS or Google keys. All right, so in this, you can create a key ring, right? And you can have this go regional or global, I believe. So this lets you create, rotate, and manage your keys. The keys are resources that are used for encrypting and decrypting data and for verifying digital signatures, right? So this is where you create it. You set it to regional, multi-region, or global, right? And have it available at your own need, right? You can also do this through the GUI as well. So this command, Let's see. I'll switch to the active window. This command, G-Cloud KMS keyrings, create my keyring. Location global would create that keyring. Or you could create a key within the keyring, okay, with another command. And I'm going to copy and paste that over as well. Right? So it would be G-Cloud KMS key, create my key, location, global, keyring equals my keyring, purpose, encryption, right? So that's another way to do that. And you can use these keys with the GCS bucket, right? So how would you do that? Well, you would encrypt this bucket within a project ID. I'll show you here. GSUtil KMS encryption key K to the projects with your project ID, locations, global, keyrings, my keyring, crypto keys, my key on the specific bucket. And with this, you get a key that is encrypted or able to encrypt. And this one in particular would encrypt your bucket. And you supply customer service keys as well. Now you'd have to use this with your own local key, but let's say if you want to use a customer supply key, this is one command you could use. OpenSSL rand base64 encryption for my encryption key.text. All right. And I believe that would give you the Republic and private key. And then you could use the key when creating, let's say, a disk. So you would use this command, which I'll give you right here. All right. All right. G-Cloud compute disks, create my encrypted disk with this customer supplied key, my encryption key. Right. And so that uses the key you just created. All right. So in the exam, this will test your knowledge of Google's encryption options, including when to use customer managed keys versus customer supplied encryption keys, and how to properly implement them. You'll need to identify appropriate encryption solutions for various compliance requirements. 5, internet communications, securing data in transit. Google Cloud secures data transmitted over the internet using multiple layers of protection. How do you implement it? Well, you can use private Google access for VM instances. I believe we tried that in an earlier chapter. Now, you would find this here, and I believe it would be under the network. Okay. Now I'm going to reconnect this over here. I'm going to use that for my CLI work. Now, when I used this last time, I believe, private Google access is used where? No, not in network security. Not in compute instances or compute engine. I believe it's under the peering. Let me see. Private Google access. So this is over here. Let me get a brief. Okay. So this is VM instances that only have internal IPs, and so you want to use resources internally. That's what I believe it is, right? So it would probably be under the compute engines, but it's not going to be directly related. Right? But in general, you could create a subnet with private Google access and then configure an SSL certificate for a load balancer. And with that, you would be able to use your internal services and then have some opening to the public internet to have outbound transmission. So within this, you'd be looking at how does your Google Cloud include private Google Access, VPC service controls, and SSL TLS implementation so that you'd be able to communicate securely? So in summary, here's some of the security layers and implementation. For the service deployment layer, your implementation approach is going to be to use service accounts with minimum privileges. Key commands would include G-Cloud IAM service accounts, create, or you'd use the IAM console, which we showed earlier. For the user authentication, part of it would be the layer would be the user authentication. That would be enabling two-step verification or security keys. And the ways you would do that would be with the Cloud Console or with the CLI. Then the next layer would be data at rest. With data at rest, you can implement that with customer managed or customer supplied encryption keys. You could do that with the Cloud commands on the CLI, or you could do that in the GUI. And finally, the layer for network security would be for configuring private Google access through SSL. And you would do that with Cloud Compute Networks commands or in the VPC console. Yeah, I was right. It was in the VPC console. I can't find it here. But that's okay. Just giving that the basic information here. All right. I am the gatekeeper of cloud access. Identity and access management controls who has what level of access to which resources. Let's explore how to effectively implement IAM for your Google Cloud architecture. So the members and their types. IAM recognizes several types of identities. Type 1, Google accounts. Google accounts. These are for individual users. These are for developers, admins, and analysts. Type 2, service accounts. These would be non-human identities. These would be used for apps, VMs, or functions. Type 3, Google Groups. These would be for collections of accounts. These would be for team access management. And type 4, Cloud Identity Domains. These would be for organization accounts. And this would be for enterprise identity. So how would you set this up? One, you could do it in the cloud, in the GUI, by going to the service accounts. You create your service account. And when doing this, name, ID, and you would go add your service account and add a key within that service account. So let's see if I can go back to this and see the key. And you can add a key, which would be in JSON. You could create a new existing key or upload one, like a customer supplied key, and use it that way, right? Or when you create it, you'd see it listed here. So when you manage Google Groups, you would create and manage them also here. Let's see. Groups would be managed here. And these would be able to assign roles to groups rather than to individual users for easier management. So the exam will test your understanding of different identity types and how to properly manage them, including service accounts, key management best practices, and proper group usage. So the most important roles and permissions. IAM users use roles to group related permissions. Here are the three types. 1, primitive roles. These are basic for broad access. Owner, editor, viewer would be good examples. Number 2, predefined roles. These would be service specific, like storage admin, BigQuery user, storage object viewer. Number 3, custom roles. These would be organization specific. These would be a custom combination of permissions. So how do you work with roles? Well, you can create and grant a defined role. This would be done in your projects under IAM policy binding, right? So let's see if we can find policy. So these are policy troubleshooter, policy analyzer, for projects. So this requires an organization. So it would be here, and you could go here and add this. But let's see if you can do this in. Let me see if this service account might let us do it. Permissions. Permissions would be the closest analog to this because you want to bind this, but your best bet would be creating a role itself. And with that, you basically want to create like a custom storage role for something like storage access and then be able to label it for what permissions. So you'd have the buckets be able to get them, be able to list them, be able to view them, be able to delete them, be able to create them. Those would be the basic things. And you create the custom role name based on the project ID, and you would use this all in a YAML file. And you could actually upload this YAML file with the permissions. And then you can view the roles, which would be in this group setting, and be able to see how your organization has its roles defined. So on the exam, this will test your knowledge of when to use each role type and how to properly implement the principle of least privilege through role assignments. So IAM policies. These are what bind it all together. IAM policies connect members to roles on specific resources. They can be set at different levels of the resource hierarchy. First level, organization. This is for all projects. This would be G-Cloud organizations for adding IAM policy binding. Second level, the folder level. This would be all contained projects, right? So this would be adding this for the resource manager on the folders and binding the policies to all of these, right? Third level, project. This would be all the project resources, let's say in the one project we're in. And so this would add the policy to this project. And then the fourth level, the resource. So you do a very specific resource like compute engine, right? So VM instances could have a very specific policy or with specific commands. And this can be done in the GUI or in the CLI. Now, automation would allow you to do both, but some people feel more comfortable in the GUI. I think you should get better at both the CLI and the GUI. So the exam will test your ability to apply appropriate IAM policies at the correct level of the resource, that folder, that project, that resource, organization. Which one is it? And then it'll help you understand how policies get inherited. So be prepared to identify the most efficient way to apply permissions across multiple resources. Cloud KMS, managing encryption keys. So Cloud Key Management Service, aka KMS, provides secure management of cryptographic keys. The key components are in these 5 levels. 1, the top level is project. This contains all KMS resources, right? The next one would be location. This would be the regional or global placement. So it goes from project to location. 3 would be key ring. So this would be a group of related keys. It would go project to location to key ring. 4 would be key. This would be the actual encryption key. And this would go from project to location to key ring to key. 5 would be key version. This would be a specific version of a key. This would go from project, location, key ring to key version. So you would create this by going in the GUI or in the console. Now let's see in the console where we are. Okay. Key management here. And we showed you earlier with the G-Cloud. So this would be the command you would have. G-Cloud KMS keyrings, create my keyring for the location global. That key create the key ring. And then within that, you could create a key. And then you could also rotate a key. And then you could apply that key or rotate that key, or most likely, more often, use it to encrypt data very specifically or decrypt data. So when you use this with Google Cloud Services, your top goals are to protect cloud storage data or other resources, or create a disk with KMS encryption. So you could do this by using the GUI or by using the CLI here. So the exam will test your understanding of KMS concepts, like key rotation strategies, integration with other GCP services, and you need to be prepared to identify the appropriate key management solution for various security requirements. Cloud security scanner. Let's see if we can find that. Why isn't this finding it? Well, that's not exactly what I was looking for, but I think this might be it. So, okay, let me enable that API. Okay, so Cloud Security Scanner automatically scans your App Engine applications for vulnerabilities. Yeah. So how do you implement this? Well, one, you're going to access the security scanner. In the cloud console, you go to security and web security scanner, right? So you can create a configuration here, either in the GUI, right? And then from here, you could set this with the display name, the URLs, and then the target platform. All right. And then you can run a scan. So here's the name, the starting URL. You can add the excluded URLs and then run scans. Save it and you could run it. You can also do this from the CLI. I'll give you that. So this would be an example of what you could run. Okay, G-Cloud Web Security Scanner, scan configs, create my scan config with the display name my scan config with the starting URL at the app, and then the target platform, the compute. All right. So then you'd run the scan and then view the scan results. In the Cloud Console, you could go to Web Security, and then you'd see the scan configs. When you click the new scan, once you save it, here you would see scan results once you've run that scan. So be aware, this only supports App Engine standard environment, and it may generate false positives, and it can leave test artifacts in your application. So the exam will test your knowledge of security scanning options, their limitations, and appropriate implementation for different application types. Be prepared to identify when security scanner is appropriate to use. All right. Let's see if we can find the next one. Data loss prevention. Okay. Sometimes it's easier. There we go. I knew it was just there. Cloud DLP, or data loss prevention, helps you discover, classify, and protect sensitive data. So types of data loss, data DLP can identify PII. What is this? These would be personally identifiable information, like names, social security numbers, credit card numbers. 2, credentials. This would be passwords or API keys. 3, medical information, medical record numbers, health insurance IDs. 4, financial data, like account numbers or tax IDs. So how do you implement Cloud DLP? 1, you go to Cloud DLP in the GUI, and then you enable this API. Why isn't this? All right, let's try discovery. I think it's wanting me to do that. Sensitive data protection. You can activate it here or in the CLI with the following command: enable the DLP with that API. And you would use this to inspect content for, say, sensitive data, say a JSON or a compute engine or a storage bucket. And you would look for credit card numbers, account numbers, social security numbers. And then you could de-identify sensitive data, basically blocking it out from being viewed or seeing only the last 4 digits. And you can create a DLP job to scan the cloud storage object. So let's go here. Card creation. Okay, so this scan would look through these discovery types, select the scope, select the project or table, and then you do this on the schedule. Well, this is sensitive data protection, which is, let's see, discard this creation. Let's go to here. Why isn't this letting me? That's interesting. So it is going to have me here. Okay, so this is where you would do it, is under the sensitive data protection, which would do DLP. So you create that DLP job to scan, say, a storage bucket or a database or any sort of resource that you wanted. So the exam will test your knowledge and understanding of DLP capabilities, appropriate implementation for different data types, and integration with other GCP services. So be prepared to identify DLP solutions for various compliances. So let's try this, and I'll show you. Here are the discovery target types: the BigQuery, Cloud SQL, Cloud Storage, Vertex AI data sets, or secrets or credentials. And you can set the scope, whether to do the organization, a project, or a resource. For all of this, it can only have one configuration. And then you can set this on a schedule. By default, there's a catch-all schedule, or you could have it iterate over specific times, right? So you could add this schedule. We'll continue from here. Select the inspection template. And so this would be what it's looking for: advertising IDs, DNI number, tax filing numbers, auth tokens, AWS credentials. This looks for a lot of stuff. And let's see, all 200 of these are GCP credentials, GCP keys, phone numbers, CDIs, CDLs. This is a lot. This is a lot. Okay. And then the actions, what would you do? Okay. What do you want to do? You can do different actions. You could publish this to Security Command Center. You can save the data profiles. And then you have sample data with the discoveries. And then you could tag the resources that might actually have this. and then submit this for PubSub, where you want to send a notification about the profiles of the details of your choosing. And then you can go the fallback processing location. So sensitive data protection processes your cloud data in the same region. However, some operations are only available in certain regions. So that's fair enough, so it can process the region. And then set this to configure and store this where you would have all the data, the subsequent scan configurations. And then you could review your final configurations here and name it, and then click create. We're going to cancel that, so we don't want to have this running. Next up, security keys and two-step verification. Security keys provide strong multi-factor authentication to protect access to Google Cloud resources. So there's types of second factors. One would be SMS codes. This would be text messages. This is a low level of security and it's pretty basic, but it's a good way to get started. Number two would be your authenticator app. There's a Google app, there's Okta, there's dozens, well, there's several authentication apps that are trusted. This would be a medium app, medium level of security. And it's pretty standard. You should have this. And then the third would be a security key. This would be a physical device that you would use. This would be the highest level and is good for high security environments. So how would you implement this? Well, we already showed you in this security earlier, but it never hurts. So that's right, we didn't find it. Ugh. Multi-factor here. Recaptcha looks like the way, right? That's what we did earlier. Two-step. That would be one. So you want to enable it and enforce security keys for the sensitive roles, right? And so this would be done in your security so that when you log into your environment, here you go. Here's a key. And there's how-to guides for all of this that you can go over as well. So your best practice is to register at least two security keys per user, a primary and a backup, and then store them securely, meaning not in somewhere publicly accessible, somewhere where you only know what it is and where it's supposed to go. And you could use an online service as well, something like Titan Security Keys or something like a Vault service. So the exam will test your knowledge of all the authentication methods, the relative security strengths, and appropriate implementation for different roles and access patterns. Be prepared to identify the most secure authentication solutions for various scenarios. So as you prepare for the Google Cloud exams, focus on these key concepts. The shared responsibility model. Understand which security aspects are Google's responsibility versus yours. Typically, it's physical is theirs. All the application security and encryption is yours. Know how to properly implement your security responsibilities. Number two, defense in depth. Implement multiple layers of security controls. We talked about the IAM, we talked about the service accounts, we talked the customer keys, we talked about the two-step verification, the multi-factor authentication. So you never rely on a single security mechanism. Number three, the principle of least privilege. We talked about that with the IAM, how you can limit it to the scope of a project or folder, a different service account. And within that, you can limit it to different permissions that allow, but that default denies. So grant only the permissions necessary for the job. Regularly review and audit the permissions. Number four, security best practices. Use service accounts appropriately. Implement proper key rotations. Enable appropriate logging and monitoring. And then understand encryption options like customer managed or customer supplied encryption keys. Number five, compliance requirements. Understand how GCP services help meet compliance requirements. Know which services are appropriate for different compliance needs. By mastering these security principles and implementation details provided, you'll be well prepared for the security aspects of the exam and your usage of Google Cloud. And you'll build secure cloud architectures. So a couple of questions for the exam. One, your organization requires that all data stored in cloud storage buckets must be encrypted with keys managed by your security team. Which encryption method should you implement? I hope you said customer managed encryption keys. You do this through KMS. This lets your security team maintain control of the encryption keys while leveraging Google Cloud's infrastructure. Number two, you need to ensure that only authorized developers can deploy changes to your production environment. Which combination of security controls should you implement? IAM with custom roles for developers, and then require two-step verification with security keys for production access, and use separate projects for development and production environments. Number 3, your application processes credit card data. Which Google Cloud service should you use to ensure this data is identified and properly secured? Data loss prevention. Use that to identify, classify, and de-identify credit card information before storing it. Okay, by understanding and implementing these security controls, you'll be well prepared for both the exams and building secure applications on Google Cloud. Thank you for joining us. And next chapter, chapter 8, will be on understanding billing in the cloud. Have a good day.